tangent, we're going to talk about another concept, which is what we call a secant of a tangent. So consider this curve, f at x, that's y, that's x. So the secant to a tangent is just any line connecting 2 points, going through 2 points. Okay, so this is a secant. So that means a line going through 2 points on a curve. On a curve, or a function, whatever, or a graph. So as an example, let's say you had y equals, the easiest one, x squared, and you want to find the slope of the secant between, or going through, I'll say between, let's take the point 1, 1, so 1, 1's on that curve, and let's take 3, 9. So we know that x squared looks sort of like that. So 1, 1 is here. So that's 1, 1. And then 3, 9 would be up here. So we want to find the slope of the line going between them. So m would equal, how do you get the slope? y2 minus y1 over x2 minus x1. So that would be, let's say 9 minus 1 over 3 minus 1. So 8 over 2. So the slope of this line, this secant, therefore the slope of the secant is 4. Okay, so that's slope of a secant. Now, how is that related to the slope of a tangent? Or what is a tangent, I guess we'll say first. So a secant's a line going between 2 points on the curve. And a tangent is sort of, well, I'll draw a tangent first, okay? So a tangent doesn't go through 2 points, it actually only goes through 1 point. But it goes through it sort of in a special way. So, this is the point I want to go through. Now there's lots of lines going through there, right? I could draw a line like this, like that. They're only going through 1 point. But what the tangent is doing is, what you can think about it doing is it approximates the curve around that point. So if you zoomed in on this point, so let's say we zoom in, zoom in, then you're going to have just like this part of the curve, it's almost going to become straight, right? It's just a little curve, and then that's the point. So the tangent, the more and more you zoom in, the more it looks like a straight line, the curve, and the tangent's the line that, looks like the curve if you zoom in enough. So that's what it is. Sometimes people define tangent as it's the line that passes through 1 point on the curve, which is, it's not a good definition for 2 reasons. The first being, we saw in this example, there's lots of lines that pass through 1 point, but there's only one that, follows the shape of the curve. And the other thing is sometimes you get curves like this. So what if I wanted a tangent at this point? Well, it's going to do this, but then it'll pass through it at 2 points, right? So a tangent could pass through it at more than 1 point, and there's more than one line that passes through the curve at 1 point. So you have to define tangent as, the best way to define tangent is approximating the curve if you zoom in enough. Okay, so now the question is, how do we find the slope of this tangent? right? In order to get the slope of a line, you need two points. So you need 2 points to find the slope of a line. Right? But in this case we only have 1 point. So here's what we're going to do. Let's draw another graph. So let's say I want the slope at this point. So I'm going to use this point. Let's call that A. Okay. What I'm going to, so I want the slope, I want this line, that's the tangent. So what I'm going to do is, I'm going to take another point. I'm going to take this point here. Let's call this one X. So this one's A, then the coordinates of this point are F at A, because this will be the curve F at X. This coordinates would be X, F at X. Okay, so now look at the secant right here, going between A, F at A, and X, F at X. So that doesn't look all that much like the tangent, right? It's clearly a lot steeper, but what I'm going to do is, I'm going to let X, or this point, slide along this curve. I'm going to let X approach A, or get closer and closer to A. So this is going to, move along down, and as you move down, the slope is going to get closer and closer to the slope of that tangent. So the way we're going to find slope of a tangent will be so it's going to be the slope of this secant line. So that'd be y2 minus y1 over x2 minus x1, which is equal to f at x minus f at a over x minus a. So this is the slope of the secant line. But what do we need to do to make it the slope of the tangent? We're going to let x go towards a. So we're going to take the limit as x goes to a of f at x minus f at a all over x minus a. So this is one of our definitions of the slope of a tangent. Okay, so here's our example. We're going to find the slope of the tangent to this curve, f at x equals x squared, at the point 1, 1. So x squared looks like this. So 1, 1, 1. And then if you remember, we're going to have to take another point. We're going to call this x, f at x, and in this case f at x would be x squared. So we're going to find the slope of that line. So that'd be y2, which would be x2 minus y1, which is 1, all over x minus, so x minus 1. So m equals, but we're going to take the limit as x goes towards, so as this is x, this is 1, so we want x to approach 1. Okay, so now we just need to evaluate this limit, which we saw how to do previously, right? You can't use direct substitution because if you put 1 in, you get 0 over 0. So we try a strategy of factoring the top. So factors is the difference of squares. The x minus 1's cancel out. So limit as x goes to 1 of x plus 1. And now we can use direct substitution. So 1 plus 1 equals 2. So therefore, this is the slope of the tangent. I won't even write it. So the slope of the tangent, the slope of this line, must have been 2 at this point. Okay. So that's how you get the slope of the tangent at a point. Okay, now quickly what we're going to do is just look at another sort of formula or another way to get the slope of a tangent. It's really the same way, right? It's just you're going to use different variables, and this tends to be easier with calculations, and it's used more. So this is the point A. We want to find the slope of the tangent at this point. So that's still going to be the coordinate A, f at A. You can do the same thing. You're just going to take another point and let this other point move towards A. But now instead of calling this x, instead of saying this x, we're going to say this is A and a bit, right? This is A and it's a little bit more than A. So we're going to say it's A plus h. So this distance in between here is h. So what are the coordinates of this point? Well, it's A plus h, f at A plus h. And then we're going to take the limit as A plus h goes towards A, or really that's just as this thing, this distance h is going to 0. So as this gets smaller and smaller, this point moves along here and gets there. So m would equal the limit as h goes to 0 of y2, which would be f at A plus h, minus y1, which would be f at A, over x2, which would be A plus h, minus x1, which is A. And then notice the a's cancel out. So m would equal the limit as h goes to 0 of f at A plus h minus f at A over h. So this thing right here is the slope of the tangent at A. Slope of, and you're going to see that this equation is very, very important for calculus. At A, f at A. You're going to see this a lot. So this is the one this one tends to be used a lot more than the other one. Okay, so here's our example. We're going to find the slope of the tangent to the curve y equals root x, so that's this one right here, at the point 1, 1. So that's at this point. So we want the slope of that tangent. So we're going to do the same thing. We're going to take another point and look at the secant, but we're going to call this one, instead of calling it x, we're going to call it 1 plus h. So the coordinates of this point's 1, 1. The coordinates of this point would be 1 plus h square root of 1 plus h. And we're going to use the new formula. So limit as h goes to 0 of f at, it was A plus h minus f at A all over h, which in this case would be limit as h goes to 0 of f at A plus h. Well, A is 1 and f is this, so that'd be square root of 1 plus h minus 1 all over h. So how do you evaluate this limit? You might try direct substitution, but that's not going to work. You get 0, or you get 1 minus 1, which is 0 over 0. So that won't work. So how do we evaluate this limit? Well, if you remember from evaluating limits, one of the strategies when you have a square root is to multiply by the conjugate for the top and the bottom. So the conjugate of 1 plus h root minus 1 would be this. So multiplying that, 1 plus h, and the middle terms cancel, minus 1 all over h. And now notice I won't expand this. You'll see why in a second. So here my 1's go away. So I just get h over h, and then 1 plus h minus 1. These h's go away. So I just have the limit as h goes to 0 of 1 over 1 plus h minus 1, and then I can let h go to 0. So you get 1 over, sorry, this was a plus. So you get 1 over 2. So you get 1 over 2. Okay, so that's the slope. m is equal to 1/2.